Hi friends and my dear students, 12th Physics second volume and Unit 7. Today the very important heading, the effect of intensity of incident light on photoelectric current. That's a very important uh, experiment that we are going to see today. Now we have to construct the apparatus as shown in the figure to study about the photoelectric current in detailed manner. Now, let us assume that an evacuated glass tube, completely evacuated glass tube was considered as shown in the figure, and there may be an open window or quartz window, it is called quartz window, so that it allows the incident rays through this window and hit the surface of the cathode. That's why we are considered the quartz window. And then here C is considered to be a cathode made up of photosensitive plate, and it was negatively charged so that it is a negative terminals. That means whenever the light rays which falls on the surface of the cathode, it will emit the electrons, and these electrons are called photoelectrons. So C is capable of emitting the photoelectrons, whereas anode is the positive terminal and which is attract these electrons which was emitted by the cathode, so that anode is considered to be a positive terminals. Now we have to consider a potential divider which was connected with the high tension battery of P through key of K. And by this instrument, we are keeping the voltage between cathode and anode with the help of this potential divider. In case if you want to make this anode to be as a positive, then it is possible. Or if you want to anode to become as a negative, then you can modify this J here, sliding J, so that you can apply the negative voltage to the anode such that it was constructed. And now C is connected with the middle of this PQ, and anode is connected to the sliding edges of J through the potential divider, in the potential divider. Now, and micrometer and voltmeter, both is essential here. The first one is micrometer, is useful to measure the photoelectric current. That's why it was connected in serial manner. Whereas the voltmeter here mentioned is nothing but like this. Center the needle or indicates 0 on the first, in the right hand side, 1, 2, 3, 4, that is called in positive voltage. In the left hand side, it shows that negative voltage, so that such a voltmeter which is connected in this, in between anode and cathode, to measure the voltage between C and A. That's a very important apparatus that is useful to study about the photoelectric current in detailed manner. Now, this is the apparatus setup. Now, when we allow the photo rays, that means the incident ray of ordinary light ray or electromagnetic ray or ultraviolet rays, whatever it may be, whenever hit the surface of the cathode, then there may be ejection of electron. But in the absence of this ray, there is no electron, then there is no current. So, when we are applying this ray, which will hit the surface of the cathode, then automatically it will emit electron, and keeping this voltage A in positive manner so that it will attract the emitted electrons towards A, then we are able to receive the current. Now, initially we are applying A become as positive. A become as positive. What will happen? The ejection which will happen by the cathode, so that the positive anode which will attract the electrons towards this anode plate, and we are able to getting the value of photocurrent in microampere. And we can also measure the voltage in between the A and C. Sorry. Now, if you want to study about the experimental phenomena which we are going to study about the photoelectric current, what are the causes of the current? IP are generally denoted as photoelectric current. IP is the photoelectric current which will depends on incident of intensity of the incident ray or the voltage that are applied between the anode and cathode. Voltage that was applied between the terminals of A and C. Voltage between A and C. That means when you are keeping A is positive, then there may be a pull of electrons. When you are keeping A is less than the negative voltage of C, there is no electron capable to move from cathode to anode, such that the apparatus was constructed like that. Then third one, the frequency. This is called frequency of incident ultraviolet rays or light rays. And fourth one, the metallic surface which are used. Metal surface. These four is the causes for the photoelectric current. That's a very important concept. We are going to deal with the help of this apparatus, and we are analyzing this concept. What is the relation between A and C, and what happens when you are changing in the intensity, or you want to keeping intensity as a constant, you are changing the voltage, what will be happen? And or otherwise all are keeping except frequency, there may be changes happen here. That's the thing that we are going to see one by one. It's a very important thing. The first thing that we are going to see, the effect of intensity. That means effect of intensity of instant light rays means that it may be ordinary light ray or ultraviolet rays, whatever it may be. The effect of intensity of instant light rays are varied by keeping these are all constant. These are constant, and this may be also constant. What will be happen? The metallic surface is already photosensitive material are coated in the cathode. That's why it is already constant always. So that we are keeping these two is constant, and we are varying the value of intensity of instant rays, and corresponding the photoelectric current IP is also varied. Now, if you want to draw a graph, like as shown in the figure, and the photoelectric current IP is in y-axis, and intensity of the instant rays in the x-axis. This is called y-axis. What happened when you are increasing the intensity of the instant rays? Corresponding the current of IP is, suppose when you consider this is called the intensity value, then what will happen? The IP of the value is just like a dot, likewise, or like this. This is called IP. And whenever the intensity is like this point, then IP which will be in this point. Likewise, if you are increasing like the x-axis, so what IP also increases in the y-axis, like this point, like this. Then if you are adding this point, then we will get a straight line like this. So from this graph, we concluded that whenever you are applying the instant ray, by keeping constant as frequency as well as the voltage between A and C is a constant, if the variation which are happen in the intensity, then in the IP which will be increased. That shows that the interaction that was happened between the anode voltage as well as the cathode voltage, whenever the anode is positive, compare with the cathode, then it will pull the electrons. Then there is a possibility of getting current in the outer circuit, that is called photocurrent. This is a fundamental, very good example for this. Here, now one conclusion here is the most valuable conclusion. Why the intensity are increased, correspondingly the IP is also increased. What is the reason for that? That means the photoelectric current which are directly proportional to the intensity of the instant ray. The intensity of instant ray, that means R, the number of electrons emitted per second are directly proportional to the intensity. Here you have to write here the number of electrons emitted per second are directly proportional to the intensity of the instant ray. That's the thing that we are going to conclude. This is the first phenomena the intensity, how which will modify the photoelectric current and how it will impact the photoelectric current. This is the very first phenomena that we concluded. Then second thing that we are going to deal, hmm, the second thing that we are going to deal about effect of potential effect of potential difference of photoelectric current. Effect of 7.23. If you need furthermore, or I will give an excessive point, but that I hope this is enough for you. That's why I have minimized I need quality than the quantity. That's why I gave only a very important concept to you. Now, the 7.23, in the heading of 7.23, the effect of potential. The effect of potential. Effect of potential difference. Effect of potential difference on photoelectric current. Effect of potential difference. Effect of potential difference on photoelectric current. Photoelectric current. That is a very important concept of the second things that we are going to see. Now we are varying the potential difference corresponding what will be happen in the photoelectric current. That's this experimental are studied in between the relation between changes in the potential difference, anything leads to the photoelectric current. That's the thing that we are going to see. Yes, very important concept, because whenever we are applying the voltage, or positive voltage to the anode terminals, what will happen? Naturally, it will attract the electrons from the cathode. In case, if you are keeping this potential as negative, even though the electrons are moving towards the anode terminals, which will not stop. Why? What is the reason for that? The things that we are going to explain. Now, the potential A is increased and the corresponding the photoelectric current also increased. We already studied many times, not only in this experiment, in many experiments, we already go through the same concept again and again. Now we are giving more importance on the potential difference. What is the potential difference? We have to consider as in the x-axis. X-axis and y-axis is called photo current. This is called IP, and here 0. This one is positive potential difference, positive voltage. This one is called negative voltage. Here, by maintaining intensity is constant, one is intensity is constant, second is voltage is varied, voltage between A and C is varied. Third one, the frequency is also constant. This one is constant. This is also maintaining constant. A remaining fourth factor already photosensitive plate or photosensitive material of coating, which is already constant. Okay. What is the things that we are going to see here is a very important concept. You keenly observe that. If suppose you are applying positive voltage to the A comparatively C. For example, if you are keeping C is negative, anode is positive, like 2 volt, this one is called minus 5 volt. When comparatively A is greater than or positive than the C. That's why the ejection of electron are entered to the terminals of A. Yes, it is very clear. If suppose it is 0 voltage, then it was considered to be minus 3 volt. What will be happen? Whether A is considered to be positive or negative. Even it was maintained in the 0 voltage, it is higher than the value of minus 3V. That is, A is considered to be positive, so that the electrons are capable to enter the terminals of A. Are you clear? Likewise, if you consider this one is called minus 10 voltage, this one is called minus 5 voltage. That is, anode is adjusted with applying to the or carrying the minus 5 voltage, but whereas we are keeping the cathode voltage is minus 10 voltage. Even now, A is comparatively C, it is considered to be positive because very closer to the 0 is anode. That's why it is positive. Now the photoelectric emission was happened, then there is IP. Now we want to draw a graph by modifying this kind of variation in the voltage and the variation in the current. Likewise, then we will get a graph like this. Why it was started in 0 voltage, the current will be maximum. The reason is that when you are keeping cathode is negative, anode is positive, so that without applying any excess of positive voltage, the electron are capable to enter to the anode terminals. That's why initially at 0 voltage itself the current will be attained some value. Now I want to stop this photoelectric current completely, eradicated the photoelectric current. What are the steps that we are taking to stop this potential? That's a very important concept we are analyzing here. Now, if you reducing the minus voltage, suppose minus 1, minus 2, minus 3, likewise, if you are reducing minus 1 volt, then the current which will be reduced. If you are reducing minus 2, the current again reduced. If you are reducing minus 3, again it will be reduced. At last, some value, some negative value of minus V0 voltage, there is no photoelectric current. There is no photoelectric current in this circuit. So, by means of this analyzing for this circuit, what happened here? This is called cutoff voltage. What is my cutoff voltage? When we are applying this voltage to the terminals of A, no electron can able to move towards A, such that the work was such that now we are applying the negative voltage V naught to the terminals of A. There is no photoelectric current. That's why it is called cutoff voltage. That's why it is called cutoff voltage. What is my cutoff voltage? At this voltage, when we are applying this anode terminals, there is no current in the y-axis. There is no photoelectric emission. Here, when we deeply want to study about this process, what actually happened here? Initially, the electron possesses highest energy, highest kinetic energy, even though it stopped, even though it is accelerated towards the anode terminals. But before that, we must do something, some amount of work. We are banding these electrons not entering to the anode terminals. How? That's a very important thing. The charge of the electron is called E, and the voltage we are applied is called V naught, so that this amount equivalent to this work is against to this fast moving electron not entering to the terminals of A, and that's why none of the electron are entering to the anode terminals. That's a very important concept. You have to understand clearly. Okay. For here we have to keep the constant nu. For particular frequency, suppose it is initially constant value, we are maintaining the frequency of incident ray as nu1. Then there is a graph like this. Now I want slightly modified or increased the value of frequency at about nu2. First one is nu1, second one is nu2. Increase the value of frequency of incident ray. What will happen? Then higher energy of electron are emitted. Higher energy of electron emitted means higher photoelectrons are emitted. Then we are expecting much more electrons are entered to the terminals of A, but not like that. Somewhat, yes, the current is increased. Yes, the current is increased, so that we are measuring with the help of this micrometer when we are applying the frequency of nu2 of incident ray. That means if you draw the graph corresponding this value of nu2 as shown in the figure, this is also second step as a constant frequency. Now again we want to find out, again you want to increase the frequency of incident ray frequency. What will be happen? Then the photoelectric current also increase as shown in the figure. In three cases, this is called the frequency nu3, and this is called frequency nu2, and this is called frequency keeping constant. So in the first step, we are allowing incident ray frequency as nu1. The stopping potential is minus V naught. There is no change. If you are increasing the frequency of nu2 of incident ray, stopping current, or thus here saturation current. This is called a saturation point. This current is saturation point for nu1, and this current is saturated current for nu2 and this current is saturated current for nu3. But current is raised, photoelectric current is raised, but there is no change in the cutoff voltage or minus V0. The reason for that, whatever it may be the frequency that you are applying along or instant to the surface of the cathode, there may be a rises of the current, but there is no change in the voltage. This experiment shows that the voltage, cutoff voltage, less than this cutoff voltage, again, whatever it may be the frequency, there is no change in the cutoff. But in the higher than the cutoff voltage, if you are modifying the value of V0 like this, very closer to 0 or in the positive direction, it may be varied. That's a very important concept that we are analyzing this graph. We got a very good answer. Cutoff voltage is constant. Are you clear? Now, from this experiment conclusion, we understood that the photoelectric current or the voltage, cutoff voltage, which will not depend on the frequency or intensity. That's a result. The cutoff voltage which will not depend on the frequency or intensity of the incident ray. That's a very good important result we are attaining in this experiment. Are you clear now? Very good. Next, now we want to derive an expression for this. I already told what is my stopping potential. The potential that we are applying to the anode and the amount of work done which will done by the anode are not allowing this high fast moving electrons to enter to the terminal of A, then there is no photoelectric current. That potential is called stopping potential. Now, the initial kinetic energy of the electron, kinetic energy maximum, that is equivalent to, usually we can write an equation for kinetic energy of mv square of m velocity square. Here velocity means v0 square. As per this experiment, it is equivalent to EV0. I already wrote somewhere else. It is removed. It is equivalent to EV0. That means whatever it may be, the highest or maximum kinetic energy, that energy are stopped by means of work done by this anode terminals or because of this negative voltage. That's a very important concept. Whatever it may be the kinetic energy. That's why this voltage is called stopping voltage. Now, we can modify this equation. Now we want to get the value of V0 square. So that V means velocity of the electron, velocity of the moving electron. V0 square, that is equal to 2 EV. This P is voltage. Here we have to think about more cautious to write. In your textbook, V is like this. like this. This is not V. As far as I concerned, this is called nu. This is called velocity. This is called voltage, and this is called gamma. This is gamma radiation. This is called frequency. This is called voltage. Sorry, velocity of any particle. This is called voltage. So you must be very cautious to write, or if you are putting like this, nu naught, then this is called threshold frequency, not velocity. Frequency. Be cautious to write the letters. Okay. V naught square equal to 2 EV. 2 multiplied m, then divided. Then V naught. What is V naught? Therefore, V naught equal to square root of 2E capital V naught, capital E V naught divided by m. Or in other words, we can write like this also. Square root of 2E by m multiplied by square root of V naught. For our convenience, we have to substitute this value, except this value. That's why we are separating this value with the root itself. So that V naught, finally we get V naught, the velocity of the electron, is equal to square root of 2 into 1.609 into 10 power minus 19 divided by 9.1 into 10 power minus 31 into square root of V naught, the voltage V naught. Now, by substituting this value and clear value, if you bring this minus 31 to the upper side, then plus 30, then 10 power 19 cancel and 10 power 11. And remaining this, you have to cancel to each other. And finally, we get 5.93 into 10 power 5 and multiplied by root of V naught. This is the velocity of the electron, fast moving velocity of the electron. This is a very important conclusion from this chapter. Sir, instead of joule, I want to measure K maximum in joule. Then how can we write it? K maximum or written by in joule and written by in electron volt. How can you write K or E maximum? Sorry. Your kinetic energy. KE, kinetic energy maximum, or E maximum or KE maximum. E maximum. This is called E maximum, not K maximum. Sorry. E maximum, energy maximum. E maximum is equal to EV naught joule, or E maximum V naught and both combined together, then electron volt. This is unit, and this may be also called unit. This is a two fundamental equation. These are all fundamental equation that is very useful to answer for 1 mark questions and also attending the NEET exam. So you must carefully understood the concept clearly, not memorize it. Then next topic. From this, before that, from this experiment, we conclude that for the given frequency of the incident light, for the given frequency of incident light, the applying potential, the applying potential is independent of intensity, is independent of intensity, intensity of instant light, intensity of the instant light. This implies that the maximum kinetic energy of the electron, which will not depend on the intensity or any other frequency. That's a very important concept. V not depend on intensity. It's not depend on intensity. Likewise, the kinetic energy of electron will also not depend on intensity. It is free from this electron's energy is free from intensity. This is the final solution that we are obtained from this experimental result. I hope you may understand, and you have to wait 10 minutes. The next things that another two topic that we are going to explain today itself. Just take rest 10 minutes. In the next video I will clear it the another topic. I hope you may understood the experimental phenomena and the setup and the conclusion of the result. What was happened here is clearly. If you have any doubt, then give the comment. Then I will answer for all your questions. Thank you very much for all. You have to subscribe regularly to watch my video and click the bell and all bell also. Then only you are continuously able to receive all my classes, and you have to enriching your knowledge in physics. Thank you very much.